Let us look at what is called inverse operation in logarithms. Now, if you look on your calculator, you will see log. But above log, what do you see? You see something like this, 10 to the power of x. When you find the logarithm of a number with a base 10, that's one thing. But you can reverse that with exponent. Now remember, the log of 1000, well, the base is 10, is 3. But 10 to the power of 3 is 1000. You remember that? So, let's see one or two questions, well, a few questions that we could figure out using that fact. Suppose you have the log base 10. Well, you know that log without any specified base, you assume it's base 10. But I'm going to put it here for emphasis. Log base 10 of 10 raised to the power of 1 is equal to x. What would x be? Let me see something. Let's rewrite this as in the index form. 10 is the base of the log. 10 must be the base of the index form. Remember, in log form, you have 3 as the answer here. It is power. Now, in log form, you have x as the answer here. It is the power. Equal. The number that you log is 1000, and the answer in index form is 1000. So the number that we're logging is 10 to the 1. So the answer is 10 to the 1. What must x be? X must be 1. See that? X equals 1. 10 to the x equals 10 to the 1. So x equals 1. Alright. So what we have is this is equal to 1. Let's try again and see what happens. We have the logarithm with base 10 of 10 squared is equal to what? Let's call it x. If we rewrite in index form, we'd have 10 to the power of x is equal to 2. You can think about it, the base of the log to the power of this x, which is the answer, is equal to the index, alright? So 10 to the x equals 2. Now, 10 to the 2, my mistake, right? Let me redo that part again. So, how you do it? The base of the log to the power of x equals the number that you're logging, 10 to the 2. See that? So 10 to the x equals 10 to the 2. While I was concentrating too much on the 2 to remember that what we're logging is not 2. We're logging 10 to the 2. But here, what does this mean? X must be equal to 2. See? So therefore, change x to 2. So the log of 10 to the 2, where the base is 10, is 2. See that? Try again. We could use a different base 2, you know. The logarithm, base 2, of 2 to the power of 5 is equal to x. What is x? 2 to the x equals 2 to the 5. Same pattern, you follow it? 2 to the power of x is equal to 2 to the 5th power. So, x must be equal to 5. So let's get rid of this x and write our 5 here. And so on and so forth. Now, I promise you that any number you try it with, it will work. What you do? Find the log of a certain base. Find the log of that base to a power, and the answer will always be the power. So therefore, the log, and you have a certain base. Of that base to a power, let's say to the n, is going to be equal to, what do you think? It's going to be equal to n. Alright? So, it's good to remember that. You could work with it. Alright? Let's try another thing now. Let's put this in a box, make it special, and try something else. Suppose we have 10 raised to the power of log 5 and the base is 10. Let's see what happens. This is equal to x, alright? Now, remember, we want to change this from index to log form. So I just jot down in the corner here. The log of 1,000 equals 3 and the base is 10. I don't know that 10 to the power of 3 is 1,000. This is 10 raised to the power of this, of log 5 base 10. Let's rewrite it in log form. The base of this exponent or index form is 10. So the base of the log must be 10. The log base 10 off. Alright. We raise 10 to the power of 3. In log form, it becomes the answer. So we have 10 to the power of log 5 with a base of 10. It becomes the answer. The log base 10 of 5. And when we said or equal to, we get the answer 1,000 over here. Up here we're logging that 1,000. So we say equal to x, we're logging the x. Alright. So if log x equal log 5, and it's the same base, right? Then what do you conclude? X must be equal to 5. Right? See that? So x equals 5. So I can change this x to 5 because the x is indeed 5. Interesting, isn't it? Alright. Suppose and say, well, some Jamaican people would say, suppose and say, I have 3 raised to the power of the logarithm with a base of 3. And we're finding log 4. What does that give you? We say this is equal to x. Let's rewrite this in log form now. We say the base of the log must be 3 because the base of the index is 3. Right? And then we say we're finding the log of x equal to, and what do we have here? The log of 4 with a base of 3. Right? You see that? Now, x must be 4. So x equals 4. I can write that this is 4. Now I promise you, anytime you have a number in index form, the exponent as a base b, and it's raised to the log with that same base b, and you're finding the log of a number, you will always get the answer as the number. It will always work. Right? Change this to log form, and you're going to see that that will work. Alright, so here we have the two statements. The log of b, where the base of the log is b. The log of b to the n, where the base of the log is b, is always n. B to the power of log n, where the base of the log is b, is always n. Alright? So remembering those two equations will help you in understanding certain questions and how to work out certain questions. But those are the what they call the inverse operation. You're finding the log with base b and you're raising base b to the power. Those are inverse, just like when you find the square root of a number to squared, you get the number. Cube root of a number cube, you get the number, because square and square root are inverse operation. They cancel out each other and leave the number. In the same way, log with base b and b to the n are inverse operation. So log of base b and b cancel out and leave n. B to the power of log n with a base b. You're raising b to the power, that's one operation. Log with base b, that's other operation that is inverse. Alright? Sometimes raising to the power is called an anti-log. So, just like on your calculator, you have the log and it's base 10. They don't put the 10 there, but it's base 10. And then you have 10 to the x. 10 to the x, sometimes called the anti-logarithm. The anti-log. It's the inverse of the log, they call it anti-log. Alright? Alright, so that will be it for now.